Hello, today I'm going to explain about wireless sensor networks for wildlife tracking and conservation. So, in this paper, the introduction I'm going to explain about the advent of wireless sensor networks. On the other hand, presented researchers, conservations. So, in this paper, uh, I'm going to explain about the introduction. So wireless sensor networks, on the other hand, has presented researchers and conservationists with a new chances to follow movement patterns and observe wildlife behavior and acquire vital insights into the exploitation of habitat. Thanks to installing these sensors in inaccessible and isolated sites, researchers can now monitor animals in real time and record fine-grained information that was previously difficult to get. This was previously difficult to do. Additionally, to guarantee the efficient collection, transmission, and storage of data, the architecture of the sensor network needs to be upgraded. One of the most significant advantages of using wireless sensor networks for tracking animals is real-time data collection and analysis capabilities. Traditional tracking methods frequently involve manually collecting data, which can take a significant amount of effort and can only cover a certain amount of geography and time. In other words, conserving endangered species or mitigating hazards makes it possible. To track animals in national parks and reserves, a temperature sensor can measure each animal heat, and a heart rate sensor can measure its BPM. Temperature sensors measure real-time animal body temperature monitoring. The suggested system tracks the animal pulse and alerts the entry point when it's out of range. The controller communicates the animal position, temperature, and heartbeat to the applications on a mobile app over Wi-Fi. Using the GPS module, when it comes to WSN, a large selection of sensor types may be included for a goal of tracking animals. Each of these sensor types is meant to suit special criteria for research, and many options are available. The proposed enhanced version of YOLO V5M for detecting wild animals will allow for more accurate wildlife detection. Environment sensors collect data on status of habitat and any possible dangers present. It takes a look at several sensor types in use, the pros and cons of deploying the wireless sensor networks in different ecosystems, data management and analysis approaches, and more. To protect the previous biodiversity that exists in our planet, researchers and conservationists may now make informed decisions with the help of this technology. They provide a novel method in literature review. We can see they provide a novel method of gathering and transmitting data in real time, which helps scientists and conservationists learn crucial information about the habits of different animals and plants. It may be possible to use this information to help save these species. Wild animals conflict is growing in forest and farmland areas, causing significant losses and putting lives in danger. The zone must be monitored to keep animals out and avoid disruptions. Researchers have noted that usefulness of wireless sensor networks in wildlife monitoring studies for gathering information on animal populations and the habitats in which they inhabit. Wireless sensor networks enable researchers to gather information that was once impossible to acquire, enabling them to make better informed judgment about the management of conservation efforts. The IoT's primary objective is to connect and give services through many sensors. The various IoT devices near the nature reserve perimeter are used to establish an alert system. Wireless sensor networks make it easier to make educated decisions by giving data in real time on the movements of animals, the dynamics of the populations, and conditions of the environment. Using motion detection to capture animals in action is an innovative technique. Capturing movies of wild animals is challenging without moving camera operators may have to wait hours or even days to get needed video. This is necessary to meet the criteria. The long-term survival of wireless sensor networks is a crucial factor in determining the level of effectiveness they bring to efforts to conserve wildlife. It is possible to collect extensive data on animal behavior, environmental characteristics, and state of habitats when various sensors are added to these networks. Wireless sensor networks provide alternatives for monitoring that are comprehensive. WSN-based wildlife monitoring will not be successful without careful consideration given to the choice of integrated radio frequency modules. Wireless sensor networks provide efficient administration of conservation projects thanks to the integration of sensors and communication technology. It helps us better understand animals' population to safeguard ecosystem for the future. In proposed system, the methodology that we are following here in the proposed system, the wireless sensor networks are based on the principle that disparate parts such as sensors, communication modules, and data processing algorithms may operate together in harmony. The method has potential uses in wildlife monitoring and the defense of ecological systems. The sensors, which are positioned in such a way as to capture relevant data from the wildlife habitat as a whole, are the core of wildlife sensing networks. The sensors include, but are not limited to, devices that are linked to the global positioning system, accelerometers, ambition sensors, and imaging sensors. WSN sensors almost always include transceivers and low-power microcontrollers as standard equipment, which enables wireless data collection and transfer. The collected data is sent through wireless transmission from the sensors to the central base station or sync node of the network. Several wireless protocols, including Zigbee, Bluetooth, and Wi-Fi, are used to successfully carry out this connection. The data processing and analysis capabilities of wireless sensor networks are necessary for tracking wildlife. In order to get useful information from the copious volumes of raw data collected by the sensors, it is necessary to employ efficient data processing strategies. After the data have been processed and evaluated, they may be utilized to understand the behaviors of wildlife animals better and contribute to the ongoing conservation efforts. When it comes to the fundamental operation of wireless sensor networks for tracking and protecting wildlife, the seamless integration of sensors, communication modules, and data processing algorithms is most important aspect. The process of wildlife monitoring and conservation is comprised of several interconnected steps that follow for continuous collection, transmission, and analysis of data. This is made possible by WSN. To get started, sensors like GPS, accelerometers, environmental sensors, and imaging devices are carefully placed throughout the wildlife habitat to collect particular data relevant to animal behavior, movement patterns, and habitat conditions. The data is wirelessly sent from the sensors to a central base station or sync node where it is processed. The base station acts as an aggregation point for the data received from various sensors that have been put in the field and also gathers and consolidates the data from those sensors. So in proposed system, the processed data are evaluated to understand better wildlife behavior, travel patterns, and habitat utilization. Researchers can keep tabs on abnormalities in animal behavior and critical ecosystem, migratory patterns, and animal movement patterns. The insights that may be gained by analyzing data are very helpful to conservation efforts. The preservation of biodiversity, reducing risks, and protecting endangered species are all possible outcomes of conservationist efforts. Wildlife monitoring and conservation wireless sensor networks use a wide array of sensors to gather particular data. These sensors are supplied with the wireless transceivers and low power microcontrollers so that they can connect with the WSN. This makes it feasible for WSN to collect data from the sensors. By incorporating several of these sensors into animal sensor networks, researchers can achieve a full grasp of the dynamics of animals. Because of this, it is much simpler to put effective conservation plans into action and to make choices based on accurate information to safeguard and preserve endangered species and the environment in which they live. The result and analysis use of wireless sensor networks for wildlife conservation and tracking has yielded considerable result and important insights into the behavior, movement patterns, and habitat exploitation by various flora and fauna species. These findings are extremely helpful. So this figure shows a GPS tracker, accelerometer, ambient sensors, and camera traps are just some of the sensors that have been contributed to more complex picture of animation behavior. Movement, mating, feeding patterns are just a few examples of animal behavior that may be better understood thanks to accelerometer data. Sensor data provided invaluable in assessing the safety of wildlife habitats and identifying potential threats to animal populations, and it learned how local climatic changes affect species behavior and distribution from the data we collected on temperature and humidity. Camera traps and other imaging equipments collected visual data that scientists use to identify species, analyze populations, and look at some social dynamics. The animal sensing networks makes it possible to give a holistic view of animal habitats by combining and evaluating data from multiple sensors. Many types of information collected by each WSN sensor are summarized in Table 1. A GPS sensor capacity to log latitude, longitude, and altitude makes it possible to track an animal whereabouts with pinpoint accuracy. Environment sensors measure characteristics like temperature, humidity, and light intensity to perform habitat assessments. These parameters include temperature, light intensity, and humidity. So, coming to the conclusion, these all sensors, what we are doing is we are monitoring the temperature, monitoring the animal behaviors, recording different sensors we are using. So, it has been established that conservation and monitoring of animals using wireless sensor networks is an efficient method for understanding and conserving our natural ecosystems. We now have a better grasp of wildlife behavior, migration patterns, and habitat conditions, thanks to the integration of numerous sensors, including global positioning system, devices, and accelerometers, ambition sensors, and imaging units. Wireless sensor networks have greatly improved scientists' understanding of animal movement, habitat preference, and other behaviors. Based on this data, the system has instituted measures to safeguard critical ecosystems as well as species and habitats that depend on them. The real-time data collected by WSN makes it much easier to take decisive action and make well-informed decisions in the sake of animal conservation and management. WSN can provide a comprehensive picture of animal behavior by gathering, transmitting, and analyzing data from wide range of sensors. Technology has allowed us to get a deeper understanding of complex relationships that exist between species and their habitat. This allows us to create more efficient conservation measures, which helps preserve biodiversity. More study and development of WSN technology have a lot of promise to enhance animal conservation efforts in the future. By tapping into the potential of these networks, the system may work towards the future in which natural world delicate balance is maintained for future generations. These are the references. Thank you.